Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is graph transformation. In this video, we are going to discuss the rules that are required for graph transformations. The main important three types of transformations of graph are: first one, shift; second one, stretches and compressions; and third one is reflections. Part of the beauty of mathematics is that almost everything builds upon something else, and if you can understand the foundations, then you can apply new elements to the old. It is this ability which makes comprehensions of mathematics possible. There are some basic graphs that we have seen earlier. By applying translations to these basic graphs, we are able to obtain new graphs that still have all the properties of the old one. By understanding the basic graphs, we can apply the rules and do the translations. We will recognize each new graph as a small variation in an old one, not as a completely different graph that we have discussed earlier. So understanding these translations will allow us to quickly recognize and sketch a new function without having a resort to plotting points. Let me first introduce the common functions that we should know about the graphs at this time. First one is constant function. Any function with just a constant. And second one is linear function. The basic one is y equal to x. The function will be in the terms of y. It will also have the variable x. And the third one is quadratic function. Hope you all are familiar with quadratic function, a squared one. And cubic is with the power 3. Absolute value function. You can see the modulus sign on this function. And the next function is square root function. It will be just a square root of any function. And greatest integer function. Integer sign will be there. Okay, these are the basic common functions. Let me also give you the graphs of each type of the functions so that you will get a basic idea. And after we apply the rules, there will be a slight difference from the old one, I mean the parent function, and the new one after translation. Here is the graph for the constant function. Y equal to any number will be just a horizontal line. Let me give you next graph for linear function. These graphs are just for getting an idea on the basic common function. This is how a linear function graph will look like. Now let us see how a quadratic function will look like. A graph which will look like just a U. It can be on any direction. And next graph is, so this is how any cubic function graph will look like. Hope you're clear so far. Now let us see how an absolute value function graph will look like. So it will just look like a V. Next one is a square root function, and the graph for the square root function will look like this. So far we discussed the basic common types of functions and the graphs of each type. Now let us see what is meant by translation and what type of translation and what are the rules that we are going to use to do graph transformations. First, let us start with shift. A shift is nothing but a rigid translation, in that it does not change the shape or size of the graph of the function. All that a shift will do is change the location of the graph. Okay, shift can be vertical shift. For adding or subtracting a constant, we will be doing vertical shift to or from every y coordinate while leaving the x coordinate unchanged. And horizontal shift, we can add or subtract a constant from the x coordinate, leaving the y coordinate unchanged. In this situation, we will be doing horizontal shift. Vertical and horizontal shift can be combined into one expression. Shifts are nothing but added or subtracted to the x or f of x component, I mean y component. If the constant is grouped with the x, then it is a horizontal shift. Otherwise, it is a vertical shift. Let's see the rule. If c is a positive real number, the graph of f of x plus c is the graph of shifting upwards c units. The mother parent function will be shifted upwards for c units if plus c is done. And the next one, if c is a positive real number, the graph f of x minus c is nothing but the parent graph shifted downwards c unit. Okay. Let us see one example. Let me take an absolute value function as an example. Here is an example. Use the graph of the function f of x's absolute value of x to the graph of the function f of x's absolute value of x plus 3, absolute value of x minus 4. Okay, let us first draw the graph of the parent function. This is how any absolute value function will look like. I mean the parent function. Now let us start with the first one. Graph the function absolute value of x plus 3. It means we have to shift the parent function 3 units upwards. Whatever number you're adding with the original function, you have to shift it for that number of units upwards. So f of x absolute value of x plus 3 would look like. Hope you're clear so far. Now let's do the second one. Absolute value of x minus 4. It means we have to shift the parent function. There should be no change in the shape. It should be just shifted downwards. Minus some number means if you're subtracting some number, it means you should be shifting the parent function downwards for that number of units. So minus 4, it means you have to shift it to 4 units downwards. Hope you're clear so far. So this is how we do shift upwards and downwards. If you're adding a number, shift upwards. Subtracting a number, shift downwards. Okay. Now let us see horizontal and vertical shift in right side and left side of the graph. If c is a positive real number, then the graph of f of x minus c. Please notice that a constant is subtracted within the function, unlike the previous two rules. In the previous two rules, the number constant was subtracted outside the function, but here it is subtracted within the function. Then this shift is called right shift. The graph would be shifted to the right side for c units. Same way, let me give you the shift rule for the left side. If c is a positive real number, then the graph of f of x plus c is the graph shifted to the left c units. This is how the graph will look like. This is the parent function. If f of x minus c means you will be shifting it to the left side, and this one plus c. F of x plus c means shifting to the left side. F of x minus c means shifting to the right side. Okay, hope you're clear with these two rules. Okay, let me show you one example. And let's see how the horizontal shift works. For the horizontal left and right, I'm going to use a cubic function as an example. Here is an example. Please consider this example. Use the graph f of x is equal to x cubed. I mean the cubic function. To the graph f of x, x minus 2 raised to 3. F of x, x plus 4. Okay, let me take this also 3. By looking at the question itself, we can understand this question is talking about a cubic function. So let's draw the parent function. Please notice that a number is subtracted within the function, not outside the function. So if a number is subtracted or added within the function, it means we are going to do shift to the left or right. Okay, so x minus 2, f of x minus c means it will be shifted to the right. Am I right? Hope you're clear with this rule now. Okay, let's draw the graph. Let's do the transformation of this parent graph x cube for this one. X plus 4 cube. Okay, a number is added within the function. So it should be shifted to the left side at 4. Hope you're clear with this example. Okay. So you should know when to make a vertical shift and horizontal shift. And you should be clear whether to move upward or downward or left or right. So we must know that shifts are nothing but a number added or subtracted to the x coordinate or y coordinate. Y means f of x. So if a constant is grouped with the x, then it means it is a horizontal shift. Otherwise, it is a vertical shift. Hope you are clear with this shift. Let me give you the summary of the rule. First rule says f of x plus c is the shift of the graph of f of x upward c units. F of x minus c shifts the graph of f of x downward c units. And f of x plus c shifts the graph of f of x left c units. And f of x minus c shifts the graph of f of x right side c units. For all these rules, you must notice that c is a positive real number. I mean, c must be greater than 0 to obtain the graph of all the translations. Hope you are clear with all these 4 rules. Movements up and down changes change the y values of the points. Transformations that affect the y values are intuitive for shifting upwards and downwards. Movements left and right change the x values of the points. Transformations that affect the x values are counterintuitive. Up and down will affect the y value, left and right will affect the x value. So this is all about the shifting. In the upcoming videos, we will be discussing the other rules, reflections. Hope you are clear with all the points that we discussed in our today's video. In case if you have any query regarding this video, kindly let me know. See you in the next video. Have a great